Logi Prefab's wooden roof panels are designed for rapid installation and superior thermal performance. Each panel is prefabricated in the factory, precisely cut using CNC technology, and filled with dense mineral wool insulation for optimal heat and sound control. Layers of vapor and waterproof membranes are integrated during assembly, forming a sealed, weather-resistant structure. Structural rafters and predefined service voids simplify integration of electrical and ventilation systems. On-site, the lightweight panels are lifted into place by crane and secured using engineered connections and heavy-duty screws. Installation is fast and requires minimal labor, often completing a full roof shell within a day. The insulated core, combined with airtight detailing, delivers energy-efficient, low-maintenance roofs suitable for both residential and commercial timber frame construction. In Portland's drive to deliver affordable housing, engineers and builders are embracing mass plywood panels, MPP, a precision-engineered wood product made from veneer layers laminated under high pressure. Technically superior for mid to high-rise construction, MPP offers high strength-to-weight ratio, dimensional stability, and fast installation capabilities, making it ideal for cost-sensitive urban projects. Structurally, MPP replaces traditional steel and concrete systems in low to mid-seismic risk zones. Its reduced weight compared to concrete significantly lowers foundation loads, reducing excavation depth and rebar requirements. The system allows panelized floor and wall assemblies to be pre-cut with CNC routers, including slots for MEP, mechanical, electrical, plumbing, integration, eliminating the need for post-construction chases or soffits. In this 12-story building, floor plates are installed at a pace of 1 per 8 days, leveraging crane-lifted MPP units that interlock via precision joinery. The structural framing integrates bearing studs and MPP floor diaphragms, enabling vertical load transfer without the need for heavy steel columns. With fire-rated MPP assemblies and acoustic detailing, the project also meets code requirements for high-rise occupancy. Overall, MPP technology reduces labor hours, accelerates timelines, and delivers high structural performance with lower embodied carbon. Building a log cabin from start to finish involves a precise, hands-on process that transforms raw timber into a functional, mobile living space. It begins with square beams, typically kiln-dried for stability, which are milled into uniform logs using specialized cutting tools. These logs feature notched ends and grooves for interlocking, ensuring a tight, weatherproof seal once stacked. The foundation is a heavy-duty trailer frame, designed to support the weight of the entire cabin. Each milled log is methodically stacked onto this frame, forming the walls layer by layer. Alignment is critical. Logs are secured using lag bolts or heavy screws to maintain structural integrity. Once the log structure is assembled, the exterior is hand-sanded to remove rough edges, splinters, and machining marks. A pitch timber roof is then constructed, fitted with sheathing, waterproof membranes, and finished with a metal or shingle covering. This protects the structure from rain and snow. After roofing, a protective wood stain is applied across the entire cabin exterior. This stain enhances the natural wood appearance and safeguards it from UV rays, moisture, and insects. The finished cabin is rustic yet refined, portable, insulated, and ready for off-grid living, weekend escapes, or permanent use. KLIK is a revolutionary cross-laminated timber (CLT) wall system designed for fast, simple, and tool-free assembly. Engineered with lightweight panels and unique screwless joints, this innovative system enables 4 people to build a complete wall structure within just 24 hours. Each panel locks securely into place using a patented interlocking mechanism, eliminating the need for nails, screws, or specialized hardware. It's as intuitive as building with Lego, yet robust enough for real-world construction. Whether you're erecting small structures or full-scale housing walls, KLIK delivers exceptional precision, durability, and efficiency. No cranes, no additional framework, no site supervisor, just smart design and hands-on functionality. This system empowers DIY builders, small teams, and off-grid construction projects by making solid timber wall installation accessible, scalable, and lightning fast. Perfect for modular homes, cabins, or rapid response structures, KLIK sets a new benchmark for modern timber construction. It's not just a wall system, it's construction reimagined. This wooden house was built without nails or glue, using a precise interlocking joinery system called Notorial technology. It gets underway by double waterproofing on the foundation to prevent wood-to-concrete contact. A large baseboard is laid, followed by a binding beam to raise wall height. Then 2 perforated planks, each 3 meters long, are layered with offset joints. These planks have pre-drilled holes for dowels, nagels, ensuring perfect alignment. The lower and upper perforated beams are joined hole-to-hole, dowel-to-dowel, and temporarily supported by vertical posts. Workers then insert vertical elements between these beams and secure them using horizontal and vertical wooden dowels, conts. Central posts are locked into position with tenon and groove joints, pounded into place for tight connection. Each structural unit is anchored with 6 dowels, 2 top, 2 bottom, and 2 side, creating a solid, glue-free, monolithic timber frame. This method allows wood to work with wood naturally, ensuring stability, durability, and sustainability. Ono block assembles like Lego, intuitive, modular, and endlessly adaptable. Each block clicks into place with precision, creating furniture that's strong, stylish, and space-efficient. Build, reconfigure, and personalize with ease. With OnoBlock, smart design meets playful assembly for modern living made simple. In the heart of nature, a revolutionary wooden home rises, built without a single nail, metal fastener, or drop of glue. This is the Notorial vertical timber system, a construction method rooted in tradition, yet refined by modern engineering. Construction begins with a carefully prepared foundation. A dual-layer bitumen waterproofing membrane is applied to prevent moisture from reaching the wooden structure. On top of this barrier, a robust larch baseboard is laid, chosen for its strength and rot resistance. Above it, a thick timber beam raises the height of the wall and supports the structural system. Perforated planks form the heart of the system. Each is 3 meters long and precision drilled with dowel holes. The lower and upper rows are offset to interlock like a puzzle. Hardwood dowels, known as nagels, are driven through these holes, binding the structure without the need for screws or adhesives. Temporary vertical posts support the upper framing while walls are assembled from the ground up. Workers place vertical studs into precise slots, locking them between the upper and lower planks. Internal and external lamellae are installed next, tongue and groove boards that slide snugly into position. Each element is fastened using 4 to 6 dowels, resulting in a tight, monolithic structure. This method eliminates settling, a common issue in log homes. Since all the elements are oriented vertically, there's no vertical shrinkage to account for, no adjustable jacks, no floating windows, no compromise. Wood works with wood, ensuring airtightness and stability over time. The wall design is more than just structure, it's insulation. A 30-centimeter Notorial wall outperforms many solid timber walls. Its complex profile increases the thermal path, achieving a tested resistance value of 3.14. The result: efficient, breathable insulation without synthetic layers. Different wood types may be combined. For example, interior cedar provides a warm aesthetic and natural antiseptic qualities, while exterior larch offers durability and resin-based protection against the elements. This hybrid approach enhances longevity and comfort. The system's modularity makes it ideal for remote or off-grid sites. Lightweight components, under 10 kilograms, are easy to transport and assemble without cranes. But its precision demands skilled hands. Each element must align perfectly for structural integrity and long-term performance. When completed, the result is a solid, breathable, and ecological home, crafted entirely from wood, held together by tradition and precision. A structure that blends naturally into the landscape, while standing firmly against time. This is the Notorial system, where engineering meets elegance and nature becomes home. The TrueAccess wood ceiling system redefines accessibility and architectural design. Traditionally, wood ceilings create conflict between aesthetics and access to HVAC or electrical systems. TrueAccess resolves this by integrating hardware that both suspends and allows panels to hinge down, tool-free, safely, and without ever touching the floor. Designed to work with standard 15/16 heavy-duty T-bar grids, each panel self-aligns when returned, ensuring consistent reveals without manual adjustment. Installation and maintenance require only one person, reducing risk and preserving ceiling integrity. Compatible with linears, tiles, and grills, the system simplifies facility access while maintaining the elegance of custom wood ceilings. At Wooden Street, furniture manufacturing follows a precise, step-by-step process, ensuring quality and craftsmanship. It starts with shaping the wooden planks, where raw timber is cut and processed into usable components. In Step 2, an automated machine bonds smaller pieces to form larger, sturdier planks, enhancing structural integrity. Furniture assembly follows, where parts are joined to form tables, chairs, beds, and more. Stage involves wood sanding, smoothing all surfaces for a flawless finish. Next, a non-toxic, non-VOC-based finish is applied, ensuring eco-friendliness and user safety. Finally, in Step 8, the finished pieces are dispatched through a reliable delivery network, arriving at customers' doorsteps ready for use. This streamlined process ensures every piece from Wooden Street is crafted with care, precision, and sustainable practices. Graphite anti-slip decking treatment is a precision-engineered solution applied to timber decking for enhanced slip resistance. It integrates a hard-wearing resin and aggregate insert into the board's groove, improving grip in wet or slippery conditions. The insert is factory-fitted, ensuring long-term durability without affecting timber performance. Tested to BS 7976 standards, it's ideal for high-traffic areas, ramps, and family gardens. Technically robust and easy to maintain, it offers a safer, weather-resistant surface without altering the deck's structural integrity. Building a log cabin in less than a day is possible with a well-planned prefab system and an experienced crew. The process begins with pre-cut, numbered logs that arrive on-site, ready for rapid assembly. Each log is milled with precision notches and tongue-and-groove profiles, ensuring tight joints and fast stacking without adjustments. The cabin is constructed on a prepared foundation, either a concrete slab, piers, or a reinforced trailer frame. The first logs are anchored securely to the base, forming the starting layer of the walls. From there, the team stacks the logs in sequence, interlocking each piece with the next. Because all cuts and openings for windows and doors are prefabricated, there is no need for on-site measuring or sawing, which greatly accelerates the build. Once the walls are up, roof trusses or beams are added, followed by sheathing and weatherproof roofing materials, such as shingles or metal sheets. Doors and windows are installed next, sliding directly into the pre-cut spaces. Finally, the structure is sealed with protective finishes. This streamlined process, combining CNC milled precision with modular design, enables the full cabin shell to be completed in under 24 hours, delivering both speed and quality in modern log construction. A sturdy and mobile workbench is the heart of any efficient workshop. In this build, simplicity meets strength, creating a versatile, easy-to-move bench that's ready for any task. The project begins with precise planning, laying out the measurements and defining each section. Every cut is made with care to ensure perfect alignment during assembly. Construction starts with the feet. Thick timber is measured and cut to form 4 robust legs, the foundation for the entire frame. These will support not just the weight of the structure, but the demands of daily work. Next comes the upper frame. Horizontal beams are secured tightly to the legs, forming a rigid top structure. With strong wood screws and square alignment, the bench begins to take shape. Then, attention shifts to the lower part. Shorter braces are measured, cut, and installed to complete the base frame. This lower structure adds crucial stability and prepares the bench for shelving. Once the main frame is assembled, the full structure stands solid, square, firm, and level. It's now ready to move. Four heavy-duty casters are installed, 2 fixed and 2 swivel with brakes. These allow the workbench to glide easily across the workshop floor and lock securely in place when needed. The lower shelf is cut to size and fitted inside the bottom frame, providing extra storage for tools and materials. Finally, the top work surface is mounted, a thick, smooth wooden board, screwed down tightly for maximum durability. This is where the action happens: sanding, cutting, drilling, and building. The finished mobile workbench is a strong, reliable companion in any workshop. Designed for flexibility, it moves where it's needed and stands strong under pressure. Simple to build, but powerful in performance, it's the perfect DIY upgrade for any maker's space. This clever picnic table transforms in seconds into a bench chair. With just a flip and a slide, it goes from outdoor dining to casual seating, perfect for balconies or small patios. Need a step up? A wooden chair doubles as a sturdy ladder. The backrest unfolds to become stable steps, ideal for reaching high shelves without storing a bulky step stool. Here's a wooden shelving unit, but watch closely. With a simple fold, it turns into a fully functional desk, books by day, workspace by night. It's smart design with double purpose. In the kitchen, flexibility is key. Mobile countertops roll out when needed and tuck away effortlessly, opening up space for movement. It's convenience without compromise. Dining tables are no longer static. This wooden table expands to welcome guests and retracts to reclaim precious floor space. Its hidden leaves and smooth mechanism make it both elegant and practical. In a world where space is precious, creativity becomes essential. Enter the world of smart, space-saving furniture, designed for tiny apartments, compact homes, and minimalist living. These furniture designs combine function with ingenuity, offering comfort without clutter. Each piece adapts to the moment, transforming, folding, sliding, and disappearing when not in use. Even the bed plays along. Folded neatly into the wall by day, it frees up the room for working, exercising, or relaxing. Some models even double as a bookshelf or a cabinet, an entire wall of utility in a single unit. For city dwellers, students, and minimalists alike, smart furniture brings freedom to small spaces. It's not just about saving room, it's about reimagining it. Living big in a small footprint, one fold, one slide, one transformation at a time. Sculpted elegance meets precise craftsmanship in the making of the Lattice chair by Artisan. Every piece begins with carefully selected hardwood, typically walnut, oak, or ash, dried and seasoned to perfection for stability and strength. The chair's sleek, curved components are shaped using CNC milling machines, ensuring accurate contours and seamless joinery. Each leg, armrest, and backrest is milled from solid wood, preserving grain continuity and providing structural integrity. The organic design of the Lattice chair demands exceptional precision, particularly at the joints where flowing lines converge. Artisans woodworkers employ traditional mortise and tenon techniques, hand-fitted to exact tolerances. Dry fitting is performed before final assembly to ensure flawless alignment and balance. Glue is applied, and components are clamped in place using custom jigs that preserve the chair's signature curves. Each Lattice chair is a testament to artisans' commitment to timeless design and enduring craftsmanship. The final product is not only functional but sculptural, a seamless fusion of tradition, innovation, and respect for natural materials. Once assembled, the chair undergoes extensive hand sanding. Every edge and surface is smoothed with increasing grit levels to achieve a velvety, tactile finish. The ergonomic backrest, which appears effortlessly suspended, is meticulously refined to ensure both comfort and visual lightness. No chemicals or artificial coatings are used. Instead, the wood is treated with natural oils and waxes that enhance the grain and allow the material to breathe over time. This eco-conscious finish deepens the color and adds warmth while retaining the chair's natural character. The SF1000 hydraulic nailing machine is an advanced solution for high-volume pallet manufacturing, built to deliver precision, speed, and consistency. Designed for both stringer and European block pallets, it supports dimensions ranging from 800 to 1500 millimeters in length and width, with pallet heights between 80 and 160 millimeters. The process begins by feeding wooden components into automatic molds. These molds hold the pieces in place, ensuring perfect alignment before the nailing stage. Equipped with powerful hydraulic systems, the SF1000 uses multiple nailing heads that drive up to 36 nails simultaneously. The machine accommodates nail sizes from 35 to 100 millimeters, ensuring secure joints and rigid construction. A 180-degree flipping table repositions each pallet for multi-angle nailing without manual intervention, greatly enhancing efficiency. Once assembled, finished pallets are stacked automatically, using a hydraulic stacker that can handle up to 20 pallets per cycle, reaching a height of 2.8 meters. With a production rate of 4 to 6 pallets per minute, the SF1000 supports around-the-clock output for demanding operations. The system integrates high-quality components, including Siemens PLCs, Schneider electric parts, and AirTac pneumatics. Its intuitive touchscreen interface allows operators to monitor performance, control sequences, and adjust settings in real time. Despite its heavy-duty performance, only 4 to 5 operators are needed to run the entire line, which occupies approximately 35 by 5 meters of floor space. Mold changeovers between pallet types are straightforward, though they may require a few hours depending on configuration. Certified to CE and ISO standards, the SF1000 is engineered for reliability and comes backed by comprehensive after-sales support, making it a key investment for large-scale pallet production. The SF9026 semi-automatic horizontal nailing machine is engineered for efficient stringer pallet production. Designed for pallets with lengths from 700 to 1500 mm and widths from 700 to 1300 mm, it accommodates heights between 90 and 130 mm. The system supports 2 to 4 stringers per pallet, with nails driven in a straight line pattern for consistent structural integrity. Operated by a single worker, the SF9026 ensures high productivity, delivering 300 to 400 pallets in an 8-hour shift. The horizontal nailing platform enhances stability during assembly, reducing manual handling and improving accuracy. Ideal for medium-scale production environments, this machine offers a reliable and ergonomic solution for stringer pallet manufacturing. From a humble blend of clay and graphite to a perfectly sharpened tool of creativity, the journey of a pencil is a fascinating blend of chemistry, engineering, and precision craftsmanship. What seems like a simple writing instrument hides a world of intricate processes and meticulous detail behind every clean line it draws. The process of pencil manufacturing follows a carefully structured sequence, combining raw material preparation, automated machinery, and detailed quality control. It begins with the production of the pencil lid. A precise blend of graphite and clay is mixed to achieve the correct hardness, then extruded into thin rods and air-dried. These leads are immersed in a wax bath to enhance smoothness during writing. Colored pencil leads are made with pigments and binding agents, following a similar shaping and drying process. Next, wooden slats, commonly made of cedar, are milled with grooves to house the leads. A layer of adhesive is applied to the grooves, and leads are inserted with care. Another grooved slat is pressed on top, creating a sandwich-like structure. This bonded piece passes through a heated drying wheel to secure the glue. Once solidified, the blocks are milled into pencil shapes, round, hexagonal, or triangular, using high-speed cutting heads. In the painting and stamping stage, pencils are coated in multiple layers of paint, mixed to precise color specifications. After each layer, drying ensures durability. A hot stamping press prints logos, hardness grades, or color codes in foil. Pencil ends may be dipped in colored lacquer for quick identification. These painted pencils are sent to a drying room for final curing. The final phase includes sharpening, testing, and packaging. Automated sharpeners create clean, uniform tips. Visual control systems and human inspectors check for misalignments, surface defects, or lead fractures. Only pencils that meet all standards proceed to packaging, boxed in precise counts and prepared for distribution. The result is a product that delivers both utility and design, ready for everyday writing, sketching, or precision drafting. Staedtler Norris color pencils are manufactured using WOPEX technology, which combines wood byproducts with a special polymer to form durable, eco-friendly casings. High-quality pigment and wax blends are extruded into smooth, break-resistant leads. These are inserted into milled casing grooves, glued, and pressed under heat. The pencils are then shaped, coated with several layers of lacquer, foil stamped, and dipped in color. Each pencil is visually inspected to ensure quality before being sorted and packed for distribution. The single-barrel 106 vintage pencil is crafted through a meticulous process. Wood slats are first shaped precisely, forming the pencil's classic profile. Each barrel then undergoes imprinting, where branding and identification are stamped onto the surface. Finally, tipping adds the signature dipped end, completing this elegant, retro-inspired writing instrument. At the Voskresensk Pencil Factory, VKF, pencil manufacturing is a carefully orchestrated sequence of technical operations, ensuring consistent quality and durability. The process begins with the stacking of wooden slats into drying wells. These slats are then moved to a specialized drying chamber, where controlled heat removes excess moisture to stabilize the wood. After drying, the slats undergo sorting and precise calibration to ensure uniform thickness and smooth surfaces. The next step involves gluing graphite or colored leads into pre-cut grooves within the slats. Once assembled, the slats pass through a pressing process that bonds the materials firmly. Any defective units are removed in a quality control step. The pencils then proceed to the priming stage, where they receive a protective base coat. Following another inspection, they are painted in various colors and trimmed to the correct length. Each pencil is stamped with brand markings and product details. The entire process is designed to allow for efficient small batch shipments while also preserving the product's commercial appearance. This structured workflow at VKF supports high-volume production with flexible logistics and reliable presentation. From raw material to finished pencil, Staedtler combines precision engineering with time-honored craftsmanship. The process begins with mixing refined graphite and clay, forming leads that are then dried, hardened, and treated with wax for a smooth writing experience and added strength. In the final step, pencils are sorted by type, size, and grade. Automated systems carefully package them into boxes and cases, ranging from standard school sets to professional artist kits, ensuring they're protected, presentable, and ready for distribution worldwide. Next, sustainably harvested cedar or plantation-grown wood is cut into slats, grooved, and filled with the prepared leads. The slats are pressed together, forming pencil sandwiches. These are shaped into hexagonal, round, or ergonomic profiles through precision milling. The pencils are finely sanded and coated in multiple layers of lacquer, followed by accurate stamping of brand logos, hardness grades, and identification markings. Color dipping enhances the design, and each pencil undergoes controlled drying to ensure a flawless finish. Once completed, the pencils are sharpened using high-speed blades, shaping clean, usable tips ready for writing or drawing. At Staedtler's Nuremberg facility, pencil manufacturing is a precise, engineered process rooted in centuries of German tradition. Using advanced technology and optimized workflows, production begins with the selection of high-quality graphite and clay for the lead. These materials are mixed, extruded, and dried under controlled conditions to ensure strength and uniformity. Wood casings, primarily sourced from sustainably managed forests, are milled with CNC machines for consistent grooves. Each groove is filled with dried lead using automated inserters. Industrial glue is applied with precision, and the wood halves are bonded under pressure to form full pencil slats. These slats are cut, shaped, and sanded into hexagonal or round pencils. Automated painting lines apply consistent coats of lacquer, followed by rapid drying cycles in temperature-regulated rooms. Heat stamping machines imprint branding with exact pressure and alignment. Quality control includes mechanical straightness testing, visual inspections, and digital weight checks. The final step includes sharpening each pencil to an exact angle and tip length, ensuring writing readiness. Pencils are sorted and packed by size and product line for global distribution, delivering consistency, durability, and performance rooted in precise German engineering. Deep in the Lake District, Derwent's pencil factory combines tradition with modern precision, producing some of the world's finest art tools. At its core, the facility blends mechanical ingenuity, environmental responsibility, and quality control to deliver over 1,000 different color and product combinations for global distribution. Sustainable initiatives such as rainwater harvesting, biomass heating systems, and intelligent eco-lighting play a vital role in making the manufacturing process more environmentally friendly. Production begins with the formulation of the pencil core mixture. Depending on the type of pencil, the mixture's temperature is closely controlled. For standard pencils, the materials, comprising pigments, waxes, and binders, are blended at around 70 to 80 degrees Celsius. For art bars, which require a richer texture, the mix is heated to between 100 and 120 degrees Celsius. Once the mix reaches its ideal consistency, it is transferred into a mold, a step referred to as dropping the mix. At this stage, it is compressed into a single billet using 120 bars of pressure. The next step is extrusion. The billet is forced through dies with apertures ranging from 2 to 5 millimeters, depending on the pencil line. This extrusion produces long, cylindrical strands of pigment. These are immediately cut into 180 millimeter segments, the standard pencil length, using automated slicing systems. The freshly cut cores are then subjected to a baking process, held at temperatures between 70 and 120 degrees Celsius for up to 3 hours. This step hardens the cores, enhancing durability and setting their internal structure. Once baked, the cores are tested. Sample strands, called strins, are examined to assess wax absorption and core density. This ensures consistent color laydown and prevents structural flaws. Derwent operates 3 dedicated laboratories to support this stage. The first is the Quality Control Lab, where physical and chemical properties are rigorously checked. The second lab handles legislative testing to meet international safety standards, while the third is a research and development hub for innovating new products and formulations. To streamline material logistics, a computer-controlled carousel system stores up to 30,000 kilograms of raw or processed materials. Next comes the wood casing stage. Derwent uses FSC-certified timber, ensuring responsible forestry. The wooden slats are milled with grooves to accommodate the core, and then the pigment strand is laid into place. Another slat is glued over the top, sandwiching the core securely. This assembly is transferred to an RF radio frequency machine, where high-frequency energy rapidly cures the glue. Previously, this step required 24 hours of drying time at the Keswick site, but modern RF curing now completes it in just seconds. The assembled boards are then milled into individual pencils. Automated shaping machines cut the wood into hexagonal or round profiles, depending on the product type. The length of the finished pencil after shaping is a precise 178 millimeters. Following shaping, each pencil is transported through painting machines that apply up to 3 coats of lacquer. Derwent's automated lines can paint up to 16,000 pencils per hour, ensuring both efficiency and aesthetic consistency. Next is the foil stamping process. A colored foil backed with heat-sensitive adhesive is aligned with the pencil's body. Heated dies, set between 120 and 140 degrees Celsius, stamp brand names, color codes, or designations onto the lacquered surface. This creates a durable, crisp imprint on each pencil. Pencils are then grouped in batches of 144 per board and processed in high-speed lines. Footage of this stage is often shown at 10x speed to highlight the rapid throughput. The final step is packaging and distribution. Each pencil undergoes final inspections before being packed. With a legacy dating back to 1937, and with many classic models still in production, Derwent pencils have earned a global reputation. The factory exports to over 75 countries and has been recognized with honors such as the Queen's Award for Enterprise, presented by Her Majesty at Buckingham Palace. Blending modern efficiency with timeless craftsmanship, Derwent's facility continues to deliver world-class art supplies, manufactured with care, precision, and a commitment to innovation and sustainability. Deep beneath the lush green landscapes of Sri Lanka lies one of the world's purest sources of vein graphite, Ragadara Mine. This unique graphite mining process blends traditional manual techniques with careful geological strategy to extract high-quality, crystalline graphite directly from natural veins. Unlike synthetic graphite, vein graphite forms in rich, concentrated deposits, making it especially prized for industrial and energy applications. The process begins with geological surveys and core drilling to identify the most promising veins. Once targeted, narrow underground shafts are excavated by skilled miners using controlled hand tools and pneumatic drills to follow the natural graphite seams. This method minimizes damage to the crystalline structure and ensures that the highest purity graphite is preserved during extraction. Unlike large-scale open-pit mining, Ragadara relies on labor-intensive, environmentally mindful practices that preserve the surrounding ecosystem. Water usage is minimized, and no harsh chemicals are introduced during processing. After the ore is brought to the surface in carts, it undergoes a primary hand-sorting process, separating large visible flakes from the surrounding rock. The graphite is then cleaned and further graded based on flake size, purity, and structure. Larger flakes are particularly valuable for applications in batteries, refractories, and lubricants. This sustainable and selective approach allows Ragadara to consistently supply graphite with carbon content above 90%, with some grades exceeding 98% purity straight from the mine, making it one of the rarest and most valuable forms of natural graphite available globally. The tour through Ragadara not only showcases the complex engineering behind graphite mining, but also reveals a deep respect for nature, geology, and craftsmanship rooted in generations of Sri Lankan mining tradition. In the coal-rich region of Donbad, famously known as the Black Diamond area, a powerful pile loader operates with relentless efficiency. This heavy-duty machine is responsible for loading raw coal into robust HYWA trucks, playing a vital role in the fast-paced logistics chain that feeds India's energy infrastructure. As the pile loader advances toward the coal stockpile, its wide bucket scoops up large volumes of loose coal in seconds. With each pass, it turns, lifts, and deposits the black fuel into the rear bed of the HYWA truck with mechanical precision. These dump trucks are built to handle heavy payloads, and their rugged suspension systems absorb the impact with ease, ensuring rapid and stable loading. The operation runs continuously, often under challenging conditions, dust-filled air, scorching sun, and strict delivery schedules. Yet, the synchronized motion between pile loader and HYWA ensures minimal downtime. Once filled, the HYWA departs to deliver the load to processing plants or thermal power stations. This scene is a vivid representation of raw industrial power and operational coordination. From the towering coal heaps to the ground-shaking engine sounds, every element reflects the pulse of Donbad's mining heart. The pile loader and HYWA form the backbone of a supply chain that keeps the region and the nation energized. Wooden broom handle manufacturing begins by selecting straight hardwood logs. These are debarked, cut to length, and rounded using automatic lathes. The handles are then sanded smooth, sometimes varnished or coated, and finally fitted with threaded or tapered ends for broom head attachment before packaging.